Hello children, welcome to Mathematics online classes. In today's video, from Mathematics subject, Quadratic equations topic we are going to continue. In our previous video children, some of the concepts we have finished. This basic concept we have finished. Value of quadratic polynomial, zeros, quadratic equation roots, solving by factorization, solving by completing square, solving by using quadratic formula. Up to here, all these concepts we have finished children. In today's video, so we are going to discuss about the concept. So nature or character of the roots of a quadratic equation. So nature or character of the roots of a quadratic equation. About this concept, we are going to learn today. So here children, so the quadratic equation general form is ax square plus bx plus c equal to 0. Ax square plus bx plus c equal to 0. And quadratic equation will be having some solutions or roots that we can find by different methods. By completing the square, by completing the square method, or by factorization, or by Hindu method, or Sridharacharya method. So like that we have different methods to find the solutions or roots of a given quadratic equation. In Sridharacharya method, we have learned that so the x value of a quadratic equation of this form will be equal to minus b plus or minus root of b square minus 4ac by 2a. This is the solution. If you take plus, one root will come. If you keep minus, another root will come. Like that, any quadratic equation will be having at most two roots. At most two roots. So in this root value, this b square minus 4ac, which is present inside the square root. So this is called discriminant. This is called discriminant of the quadratic equation and generally denoted by the letter capital D. So on this discriminant value, whatever two roots we are getting, their nature or their character will depend on the value of b square minus 4ac, means value of the discriminant. If you want to tell the nature or character of roots of quadratic equation, first we have to find out the value of discriminant. So what is the discriminant here? The value which is under the square root, that is b square minus 4ac, is considered as discriminant of the quadratic equation denoted by capital D. Denoted by capital D. Next, here, if the D value is greater than 0, if the D value is greater than 0, in minus b plus or minus root of b square minus 4ac by 2a, if the discriminant value is greater than 0 means minus b plus or minus root of, we will get some positive number. We will get some positive number. So discriminant will be equal to positive number. Positive number. Suppose if we take 2, so then what happens? One root will be minus b plus root 2 by 2a. Another root will be minus b minus root 2 by 2a. Means the roots are real numbers. Because b is a real number, a is a real number, root 2 also a real number. Total root will be considered as a real number. So the two roots, whatever we are getting, they are real numbers. They are real numbers. Are they equal? No. Because in one root we have plus root 2, in another root we have minus root 2. So they are unequal. They are unequal. they are unequal. Means the roots are real numbers and roots are unequal. Roots, two roots are different from each other. So if the discriminant is greater than 0, if b square is minus 4ac is greater than 0, then it will become positive. Then under root, we will get a positive value, which will be a real number. So total root will be considered as a real number, but roots will be different. So that is one thing. Suppose if b square minus 4ac is greater than 0, along with that condition, if it is also a perfect square, then what we can call minus b plus or minus root of, suppose if we got 4, 4 means it's a perfect square. Minus b, if you take plus root of 4 equal to 2, minus b by 2a, one root, minus b minus 2 by 2a, another root. Means they are rational numbers. Previously they are real numbers, but in real numbers, they belong to one separate category called rational numbers. If the discriminant value is a perfect square, then we can consider the roots as rational numbers, but still they are unequal. Rational numbers also subset of real numbers only, but we can give the divide them into particular subcategory. So roots are rational and unequal. Suppose if discriminant b square minus 4ac is positive but not perfect square, so then minus b plus or minus root of 3 by 2a, minus b plus root 3 by 2a, it is not a perfect square, 3, so that's why we cannot find the root value, minus b minus root 3 by 2a. So now this can be considered as a irrational numbers. Roots are irrational and unequal. On the whole, we can call them as real and unequal, but particularly if you want to mention means, if it is a perfect square, we can tell the nature of roots as rational and unequal. If they are not perfect square, then we can call them as irrational and unequal. This is the first case, children. This is the first case depending on the discriminant value. Next, if d equals to 0, if the discriminant value equals to 0 in minus b plus or minus root of b square minus 4ac by 2a, if the discriminant value is 0, then under root 0 minus b plus or minus root of 0 by 2a, root of 0 equals to 0, plus or minus 0, no need to consider 0, minus b plus 0 by 2a, minus b minus 0 by 2a, both this value will become equals to minus b by 2a, this value also becomes equal to minus b by 2a. Means the roots are equal. And they are real numbers. Or we can call them as rational numbers. That is the second case here. Suppose if discriminant is less than 0, if it is less than 0, minus b plus or minus root of b square minus 4ac by 2a. Suppose if it is negative, minus b plus or minus root of minus 5 by 2a. Means minus b plus or minus root of minus 5 can be written as root of minus 1 into root of 5 by 2a, where root of minus 1 can be written as I, imaginary number. Means root of negative numbers does not exist, so they are not real numbers, they are imaginary. In the place of root of minus 1, we can keep I into root 5 by 2a. Means minus b plus I into root 5 by 2a, that is one root, minus b minus I into root 5 by 2a, second root. Means this part minus I root 5 is an imaginary number and minus b is a real number. So the roots are complex here. The combination of real numbers and imaginary numbers, we can call them as complex numbers. Or the roots are imaginary. The roots are imaginary and unequal. Imaginary and unequal. So like this, children, based on the discriminant value, we can guess the nature and character of roots. If a discriminant is greater than 0, roots are real and equal, real and unequal. If it is perfect square, rational and unequal. If they are not, if it is not perfect square, irrational. If d equals to 0, then they are real and equal. If d is less than 0, they are not real, they are imaginary. And unequal. So sometimes they will use the word complex also. Complex numbers. Complex numbers means combination of real numbers and imaginary numbers considered as complex numbers. Next, let's see the example. Without solving, examine the nature of roots of equations. So without solving, by using any method like factorization, squares method, formula method, without solving, we have to find the nature of the roots, so directly based on the discriminant. So here, first question, children. So we have equation 2x square plus 2x plus 3 equal to 0. If we compare it with the general equation, ax square plus bx plus c equal to 0, where in the place of a we have 2, in the place of b we have 2, in the place of c we have 3 ABC values. If we substitute ABC values in the discriminant, where b equal to b square minus 4ac, in the place of b 2 square, 4, in the place of a 2, in the place of c 3. If we substitute, 2 square equals to 4, 4 into 2 8, 8 into 3 24, 4 minus 24 equals to minus 20, which is negative. So discriminant is negative. So the roots are imaginary and unequal. So like that, without solving, directly we can tell the nature of roots. Next, second one. This is the equation. If we compare with the general form of quadratic equation, we will get a equal to 2, b equal to minus 7, c equal to 3. If you find discriminant value, b square minus 4ac value, in the place of b, minus 7 whole square, in the place of 4, 4 as it is, in the place of a, 2, in the place of c, 3, minus 7 whole square equals to 49, 4 into 2, 8, 8 into 3, 24, minus 24, which is 25, which is perfect square, because 25 can be written as 5 square. So as we got perfect square, the roots are rational and unequal. Next, we have x square minus 5x minus 2 equal to 0. If we compare with general form, in the place of a, x square coefficient is nothing, means we can keep 1 here. So a equal to 1. In the place of b, minus 5. In the place of c, minus 2. Let's find discriminant value, b square minus 4ac value. By substituting ABC values, we will get 33, which is positive, but not a perfect square. 33 cannot be written as a square of any other number. It is not possible. It is not a perfect square. So the roots are irrational and unequal. Irrational and unequal. Next one. So comparing 4x square minus 4x plus 1 equal to 0 with the general form a equal to 4, b equal to minus 4, c equal to 1. We can find out discriminant value. We will get 0. As we are getting 0 here, so roots are real and equal. Roots will always be equal when and only when discriminant is 0. Only in that particular condition, roots will be considered as equal. Next, another question, children. So for what value of m are the roots of the equation? So 3m plus 1 into x square plus 11 plus m into x plus 9 equals to 0 equal. Means for this equation, in which condition roots will become equal? Already we know the condition. Whenever discriminant equal to 0, whenever b square minus 4ac equal to 0, then roots will be becoming real and equal. Real and equal. So this is the given equation here. Let's compare with the general quadratic form. In the place of a, we have 3m plus 1. In the place of b, we have 11 plus m. In the place of c, we have 9. Let's find discriminant. B square minus 4ac value. B square means 11 plus m whole square minus 4 into a means 3m plus 1 into c means 9. 11 plus m whole square means 11 square plus 2 into m into 11 plus m square. A square plus 2ab plus b square. 11 square is 121. 2 into m into 11, 22m. M square minus 4 into 3 minus 12m. I think there is some mistake. Is it here, children? Okay, 9 also we have here. 9 into 4, 36. 36 into 3, 108m. 9 into 4, 36. 36 into 1, 36. But as we have minus here, this symbol will change to minus. So we have 1m square minus 108m plus 22m minus 86m minus 36 plus 121 plus 85. So this is the discriminant value. So here, if we do factorization, so m square, m square minus 86m plus 85. If you do factorization, if you try to find the factors, here AC value is 1 into 85, 85. To be split into two numbers such that their sum is equal to the middle number minus 86. So we can take minus 85 minus 1 so that their product is equal to 85, their sum is equal to minus 86. So the middle term can be split into minus 85 minus 1. So minus 85m minus m. Like that, we are splitting the middle term minus 86m as per factorization method. Then first two, we can take it as one group. If we take m as common, m minus 85 will remain. Next two as one group, there is nothing common. We can take 1 as common and we can take minus as common. M, because of minus common, symbol will change. It will become m minus 85. Now, m minus 85 is common. Now m minus 85 is common. M minus 1 will be remaining. But they have given that roots are equal. So discriminant will be equal to 0. We got this as discriminant. This is the discriminant value, which is equal to 0. Product of two terms equal to 0 means either first term equal to 0 or second term equal to 0. M minus 85 equal to 0 or m minus 1 equal to 0 or m equal to 85 or m equal to 1. So like this we are getting the m value. We are getting the m value. Means the given quadratic equation will be having the roots equal when and only when m equal to 85 or m equal to 1. M equal to 85 or m equal to 1. Okay, children. So remaining topics we can learn in our next video, children. So that's all for today, children. Thank you for watching our video. Have a good day.